All right, good morning, everyone. My name is Jennifer Green. I'm a PhD student in the Department of Anthropology here at UT. I'm going to be talking to you about a side project of mine entitled The Distribution of Archaeomalacological Remains from Coastal South Florida, Shellfish from the Jupiter Inlet 1 site. Now, as many of you probably know, archaeology is the study of past living cultures, and what archaeologists do to understand how people lived in the past is by examining artifacts that are basically deposited in the ground. Now, specifically, zooarchaeology examines the animal remains found within archaeological contexts. And some of the types of questions that zooarchaeologists can ask and the type of information that we can gather is really a lot of different topics that can be discussed. Specifically, we can talk about the different types of environmental habitats that people were exploiting. We can talk about the seasons in which those activities were happening. We can look at the types of technology being used to procure those resources. We can look at preferences or even taboos against certain types of species. And then we can also look at things like social status. So if there is a difference between groups of people, like let's say a ranked society, so higher and lower class people, are different food types or even parts of an animal going to different types of people scattered across an archaeological site. So for the sake of this project, I'm going to be examining shellfish, so bivalves and gastropods, distributed across a site in South Florida to try to understand that if certain species are more prevalent in specific areas of the site where we know for a fact there were different activities being taken place. And we'll get more into that as the webinar flows. So just to give you an idea of where specifically on the map we're talking about, so on the left here, it's basically the study area is going to be due east of Lake Okeechobee on the Atlantic coast. And the site is called the Jupiter Inlet 1 site, and it's situated on the south side of the Loxahatchee River at the Jupiter Inlet. So it sits at the confluence of the Atlantic Ocean, this kind of estuary system intermixing, and then you have the freshwater river flowing from the west. Now, what's important to note here is that the Jupiter Inlet is one of the few natural inlets located in South Florida. So this kind of habitat that was the habitat that was available here to native inhabitants was very rich and diverse because you had this estuary system. So the ecology of the Indian River Lagoon is extremely diverse. So by modern standards, there are over 4,300 taxa of between floral and faunal communities present in the lagoon system today. And again, that's super rich, very diverse now, even with the significant anthropogenic effects that people have had on the environment. So it was definitely a very diverse area in the past as well. And we can examine that through the archaeological material. So kind of in this photo on the left, just to situate you, the site would have been located over here. And these are about, early 1900s, like 1900s photographs. And then you can just kind of see what these little flats would have looked like that people could have exploited. So kind of just to situate you on a timeline, archaeologically speaking, there's 5 main periods of which we consider in the southeastern United States, from the Paleo-Indian all the way up to historic contact period. The Jupiter Inlet site was occupied throughout the late Archaic all the way up until historic times. However, the specific deposits that I'm going to be talking about within this paper fall between this woodland to Mississippian transition. And archaeologically speaking, across the southeastern United States, and really the whole country, this kind of transition between the woodland and Mississippian is a time when cultures were becoming more settled, more ecologically adapted to their specific environments. And during this time, you start to see basically really rise in mound building cultures, just basically further adapting to specific environments and really becoming the defined like higher complexity. Excuse me. All right, so the important thing to talk about is if anyone's ever been to South Florida, the landscape surely doesn't look like the photos that I've shown you in the previous photos. Much of the archaeological sites, especially those comprised of shell, which the Jupiter Inlet 1 site is and was, most of that shell was actually mined out in the early 1900s for road fill. Now, this photo is actually taken from the water, and this is the Jupiter Inlet 1 site, and you can see right here, this is even a shell mining cart. Now, about 2/3 of the Jupiter Inlet 1 site was mined in the early 1900s for road fill, but there's still really important information based on historic documentation that we can gather about what the actual site looked like before it was destroyed. And basically today, this is what the park looks like. I know, archaeology is a really hard thing to do, especially in Florida. It's terrible. But look at this. It's could you find where, on the picture on the left, could you locate where the mound was? Probably not. And in fact, this the mound would have been located right over here. It's kind of a little outside of this picture, but in general, this whole area would have been a large mound structure. And today, excuse me, it's protected within the confines of a county park. So it's within Du Bois. It's within Du Bois Park, which is a Palm Beach County park. What actually sits on top of it, the reason it's called the Du Bois Park is that a homesteading family called the Du Bois family settled the land in the mid to late 1800s, and they built a historic home on top of the shell mound. So that house was established in 1898. Excuse me. But before the Du Bois family settled the area, a good old man named A.E. Douglas, you guys might be familiar with him. He's the father of dendrochronology. He actually visited the site in 1883 and created the only known sketch map known from this area. Now, what's really interesting, you can see on the left side of this picture, you see the Atlantic Ocean right about here, you see the inlet, and then again, what's happening on the south side of the inlet, which is currently the present-day Du Bois Park? There's some weird scribbles, there's a lot of stuff going on here. So if you kind of enlarge that area, you can see that there's this sketch map of this elaborate like mound structure that has these linear arms coming off of them, like 1, 2, 3. There's some large shell ridges. And then you can even see here, like A.E. Douglas estimated that the entire mound was over 400 feet in length this way. Now, we have that relative I guess, measurement for how large the site would have been on this kind of like north to south angle. However, what we don't know is how tall the actual site was before it was destroyed. So today, the only part of the mound that we have left is actually this little tiny area here. Everything else has been wiped away for road fill. And the interesting part is that we can still see subsurface these different deposits. So really quickly, I'll show you show you an example of what that looks like. Now, in the map on the left, what we've done is we've geo-rectified the actual dimensions of what A.E. Douglas predicted that the site was in the 1800s. we've geo-rectified it onto a modern day aerial, and then matching that with all the known archaeological research that's been done in the area, we've been able to pinpoint exact areas and where to focus archaeological investigations. So, like I was saying, there are these linear arms that are coming off of the main mound here. And specifically, this is a photograph of test unit 8, which was located kind of on the tip of the second mound. And if anyone knows their metric system, this is a meter stick. So this actual test unit, basically, we were able to excavate it to 6 feet deep, or a little over 2 meters. And at the end of that 6 feet, we were still encountering cultural materials, but we had to stop excavating because we had reached the water table. So it was just unsafe to continue excavations. So, with that being said, consider this. If we know that this right here, this main mound area where I have my mouse is, if we know that that's today about 30 feet high, we have no idea how tall these structures were above surface, but we do know that they were at least being constructed 6 feet below the surface. So this was a very large and elaborate archaeological site. So the idea of what I'm trying to do in this project is to focus on the invertebrate remains, so specifically bivalves and gastropods, and I'm going to look at the different species distributions across the site to be able to figure out if the 4 cultural contexts that I'm going to be examining actually have true differences in the species concentrations. So the idea is to figure out if there are different species going to very distinct areas of the site, and whether it's purposeful or perhaps incidental. And through this, I have pulled previous data from 22 different test units representing 238 stratigraphic levels. So for context, a little bit of background context, each test unit that was excavated from these different studies was a 1 by 1 meter test unit, and each level represents 10 centimeter levels. So that's how we control for basically understanding time. And so you can kind of see here, you can even see in the stratigraphy from test unit 8 here, you can see that there's clear mound building, and there's different types of soils that are being used, different types of fill material, and generally speaking, that's kind of the basics of archaeological excavation, and you can kind of get a clear view of what I'm discussing here. Okay. So in a nutshell, those 4 different cultural contexts that I'm going to be talking about today represent, the first one is from on top of the ceremonial mound. So think about it in terms of like the White House. The White House is designed so it's the big White House on the hill. Everyone's eyes are focused on it, and very special people live there. And then the rest of the tourists stand outside and take photographs. So the idea is that those that lived or carried out activities on top of the mound would have been unique to this specific culture. So I'm going to be examining shellfish remains from the top of the mound. We have a pit feature, which is just I guess I should probably go over this for a second too. So a midden is basically a glorified garbage pit. So a midden basically just represents food refuse. So everything that you throw away in your trash can today, that's what would go into like a pit or a midden. So over here in this blue, again, you can notice that there's actually docks constructed here. So prior to these docks, prior to the dredging, this was actually this whole kind of area on the north side of the site was actually not underwater. So these excavations took place prior to these dock building projects. So this represents that village midden pit area. And then we have in red the mound building episode, which you saw a photograph from in the previous slide. And then we have a general village refuse area that roughly spans this area in yellow. The test units specifically don't include anything. The test units that I specifically used for the yellow blocking do not include any of the mound building test units. So they're strictly just the village habitation area. Okay, and in this slide you can see the breakdown of the different proveniences analyzed by the context and the year. And the thing to look at here specifically is that even though there's a lot of variation in the different depth at which the levels were excavated, whether that be 7 to 7 levels or 20 levels, the radiocarbon dating from each of these contexts basically reveals that there's only about a 200-year difference between the 4 different contexts, and that's also including from the top and from the lower levels of each of those contexts. So these 4 different areas of the site were accumulated quite rapidly over that 200-year period, which was, roughly AD 900 to 1100. Okay, so moving on. All right, so the general breakdown of what was found in this analysis was that there were 69 different invertebrate taxa identified. 29 of those were bivalves and 40 represented gastropods. They were procured from 2 distinct areas. One would have been the brackish ecotones within the Indian River Lagoon, and then those of the marine Atlantic coastal waters. They represented food, tools, and personal ornamentation like jewelry. But there were no individual species that represented purely freshwater upriver from the Loxahatchee River. So it was just those 2 ecotones represented. Okay, so, and again, with the statistical analysis, what I did was out of those 69 taxa, I decided to choose only those that represented a significant contribution to the assemblages to ensure that small, less represented, like maybe it was only a couple individuals, were not included so they wouldn't skew any of the results. And then I created a contingency table and ran a chi-square test to determine if the species concentrations were related or unrelated to each other. Okay, so with that being said, I'm going to switch over to R real quick. Ignore that. All right, and drag this down. So we'll focus here in this top area. This is basically just the code that I set up with my data to again look at the table. So this is the table that I created. I clipped in. And the taxa, the 11 taxa that were the most represented in this analysis are here labeled on the left. And certain taxa I did combine, just like arcs and cockle shells are two different genera. However, I combine them for reasons that I really don't have time to discuss right now. But from a zooarchaeological standpoint, it was relevant to combine certain species. And then you can see how they're broken down across the table. So after basically when you run this, I'll move this up a little bit. You can first see what the expected results are here, and then you have your standardized residuals. So we'll now switch back over to PowerPoint. So, excuse me, I totally skipped this. Well, here, give me 1 second then, I'll go back to it. With my general hypotheses, I expected that there would be similarities and different. Some of the areas would be similar, some would be different. So those at the top of the mound, the shellfish concentrations would be distinctly different from the other 3 contexts. That's kind of along the premise of kind of refer to it like the big man at the top of the mound, or you can even look at it like our modern day president lives in the White House, which is on the hill. It's the big White House, and everyone looks into the gates, but then there's all the tourists on the outside. So it creates an us versus them sort of situation. So I would expect that the taxa being deposited at the top of the mound would reflect some sort of cultural change, cultural differences more or less between the village area. And then the mound building episode I expected to be rather different just because it's an incidental kind of building episode. And then the village pit midden area in the green, or in the teal, and then the yellow area would likely represent similar taxa. So those are the overall hypotheses. And the results of that chi-square test are kind of interesting. If we just want to start at the top of the mound, because that was expected to be the most different, you see this. Wow, like what's happening with the Atlantic winged oyster? So the only area of the entire site that this species was present was at the top of the mound, which makes sense that you would see your standardized residuals being this high. But also, what's interesting here, when you start seeing nerites, the conchs and whelks, and then the Nasa shells, each of those, all of those species are marine based, and some of them, especially the nerites and the Nasas, are indicative of like very hard substrates. And then the conchs and the whelks are your large edible gastropods that were also used as like the shells themselves were used as tools, but they were also ceremonially used in nature. So again, it's very interesting to see those numbers happening on top of the mound. So perhaps the different environmental areas that were being exploited were hard substrates and the shallow seawater grasses for conchs and whelks. And then you can see that different taxa start standing out as far as those from the superfamily Telenoidea, very high in the building episode here. And I believe that just from looking at the overall archaeological stratigraphy, that the building episode actually represents secondary use of garbage material. So different types of food that would have been initially deposited into like a pit or a larger midden type of mound area would have been repurposed, almost like recycling the trash to then use it as a creation for another structure. What better way to beautify your landscape than to declutter it from distinct garbage and then create your actual mound structure out of it when you're designing your landscape. So again, these are kind of just the bigger taxa. All right, and a secondary approach to this specific example could actually be, now going back into R, could actually be confirming these results with a G-test. So you can actually run the G-test in the deducer package. You can also run it in the RV-Aid memoir package. You just have to install the for this class. You'd have to install the RV-Aid memoir. But again, you can basically see how you would set that up the same way as the table beforehand, and those results will be similar. They were similar and complementary. Okay, so as far as general conclusions from this project go, we noticed that there were differences in the shellfish distribution from this archaeological site. There was indication of differences between the top of the mound and then the village areas. These were likely differences in social and cultural activities. We did see evidence of certain taxa being used as food refuse. And then there was there were deliberate spatial differences within the specific areas of the site. And the part about this project that was important to me was that all of this data had already been analyzed throughout the years, but it had never really been put together in a concise manner. So you can actually go back and utilize old site reports from archaeological investigations, and throughout several decades worth of research, particularly this research included excavations from 1990 to 1992, all the way up until 2010, and 2011. And you can combine all this data over the years to actually create a more concise picture of the activities as far as spatially and temporally. So yeah, that's all I got. I hope you enjoyed it. This was my first attempt at ever making a video, so hopefully all the editing gets in there correctly. Thank you.